M. Victor Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to DTH channel. This is lecture 6 in astronomy and astrophysics. This lecture is about stars 2. I am going to organize this lecture in the following way. Introduction about stars, star clusters, spectral classification of stars, constellation of stars, and finally the summary of the discussion we are going to have. Stars are the fascinating objects in night sky. We know that. Many have wondered how far the stars are. What is the reason for the glittering effect of the stars? Like that, many questions are there in the humankind, in the minds of humankind. Slowly, humankind is finding answers for all the questions they have about the mysteries they see in the night sky. Stars are millions of light years away from Earth. We know light year is the distance travelled by a light in 1 year. So millions of light years means it's very far from Earth. Such far distance is the place of existence for stars. How the stars are formed? Another question often wondered humankind. Recently, they found answer for that as stars are formed due to gravitational pull of the dust and gases exist in the universe. These dust and gases are formed due to the explosion happened some 13 to 14 billion years ago. This is what Big Bang theory says for the formation of universe. So stars are formed due to the gravitational pull of the dust and gases present in the universe. Then in this universe, innumerable stars are there. We can't count how many numbers are there. Then in the formation of star, in the existence of star, stars undergo different stages in its life cycle. The stages are protostar, that's the initial stage of a star, main sequence, red giant, white dwarf, and supernova. These are all the different stages that stars undergo in its life cycle. Our sun, which is the nearest star, is currently in main sequence. Several astronomers are very fond in researching stars. Till date, innumerable stars are enumerated by the astronomers and scientists working all over the world. They have taken pictures of the stars, different star clusters in the universe using the high sophisticated telescopes existing in our Earth. This is how stars are the fond subject in research in astronomy for many of the astronomers. This is one of the photographs taken by an astronomer of the globular cluster of stars. This globular cluster of stars is named as NGC 1898. You could see many glittering balls in this picture. These glittering balls in different colors are different stars existing as a cluster. It's not sure all the glittering balls are at the same distance. No, these are all not in the same distance. They are all at different distance. Many techniques were used by the astronomers and researchers to find the distance of stars. This is one of an interesting picture of globular cluster of stars. Next, you could see an explosion in a cluster, stellar explosion in Orion. This was photographed by a sophisticated telescope, ALMA, from the Earth. This is how stars are the fascinating subject of research for many astronomers and researchers. As I told, stars are basically classified into two clusters, globular cluster and open clusters. These are the two broad classification of stars. Globular clusters. These globular clusters are roughly spherical grouping of stars that range from 10,000 to several million stars packed into regions ranging from 10 to 30 light years wide. So, in 10 to 30 light years wide, these 10,000 to several million stars are packed in a spherical group, in a spherical shape. So, such stars clusters are called as globular clusters. They commonly consist of very old population 2 stars, which are these population 2 stars just a few hundred million years younger than the universe itself. We know the formation of universe is about 13.5 billion years, 13.5 billion years away, and are mostly yellow and red. These globular clusters of stars are mostly in yellow and red color. You know, these globular clusters are so old that any star higher than G class or F class, this G class and F class are spectral classification of stars. We are going to see that spectral classification of stars. So, that time you will understand more clearly what is that G class and F class. Here in these globular clusters, these clusters are so old than any star higher than a G or F class, which have already evolved off the main sequence. I told stars undergo many stages in its life cycle. The first stage is protostar, then the second stage is main sequence. So, this globular cluster, in this globular cluster, G or F class stars have already evolved off the main sequence. Then there is little free dust or gas in the globular cluster, so that no new star formation is taking place in this globular cluster. So, that is the another thing about globular cluster. Coming to the stellar densities in this globular cluster, within the inner regions of a globular cluster, very high compared with the regions such as those around the Sun. So, densities of globular cluster in the inner region will be very high compared with regions such as those around the Sun. Globular cluster 47 TUC from the ground based ATT telescope is found that this globular cluster is about 4,600 parsecs away from Earth. You know, parsec is a distant unit used in astronomy to measure the distance of different objects. Then the globular cluster stars are about 10 billion years old. As we see earlier, these globular cluster stars are just younger than the universe. I told universe is 13.5 billion years old. So, these globular clusters are about 10 billion years old. So, many are in that red giant phase or white dwarf phase. This is the thing about the globular cluster of stars. Comparing this globular cluster with open cluster, this globular cluster had a common origin like the open cluster. Unlike open clusters, globular clusters normally remain gravitationally coherent throughout their lives. So, dust and gases present in the globular cluster will be gravitationally coherent in its category. Then the stars within the globular cluster are not dispersed out of the cluster. It is another important or unique property of the globular cluster of stars. Our Milky Way galaxy has about 200 globular clusters. Prominent examples of this globular cluster include 47 TUC, M4 and Omega Centauri. These are all some of the prominent examples for the globular clusters. Although there is some debate as whether this may in fact to be a captured dwarf spheroid galaxy. So, these examples are still have some debate whether they are all clusters of stars or galaxies. Like that things are there about globular clusters. Now, coming to open cluster, these open clusters are completely different from the globular cluster. The reason for naming this open cluster as open cluster is the individual component stars in open clusters are easily resolved through a telescope. That's a unique property of open cluster of star. That's why this open cluster of star got the name open clusters. Then open cluster stars such as Hyades and the Pleiades. This is the picture of Hyades star cluster, which is an open cluster star. Here you can see the stars far apart. Using our naked eye, we can easily distinguish the stars in that Hyades cluster. So, open cluster stars are so close that individual stars can be clearly distinguished by the naked eye. They are sometimes called galactic clusters. The reason for the name galactic cluster is their location on the dusty spiral arms on the plane of spiral galaxies. We know collection of stars constitute galaxies. Collection of galaxies makes this universe. So, this open clusters exist on the dusty spiral arms on the plane of spiral galaxies, so that they are also called as galactic clusters. As I told earlier, this is the photograph of Hyades star cluster, which is open cluster, a prominent open cluster star. Then Pleiades star cluster, this is also another prominent open cluster. You could see the stars are distinguishable even by our naked eye. That's the beauty of this open cluster. This is another star cluster. Now, stars in an open cluster have a common origin. They formed from the same initial giant molecular cloud. We know stars are formed due to the gravitational pull among the objects like gases and dust present in the universe. So, here stars in an open cluster have a common origin. They formed from the same initial giant molecular cloud. They are generally made up of young stars up to a few tens of millions years old. If you take the globular cluster, that is the youngest star comparing with the universe. Here the open cluster are also made up of younger stars up to a few tens of millions of years old, with a few rare exceptions that are as old as a few billion years. Open clusters also contain only a few hundred members within a region of up to about 30 light years. Globular clusters are about 10 to 30 light years wide, but here open clusters are wide about 30 light years. Being much less densely populated than globular clusters, these open clusters are much less tightly gravitationally bound and over time will become disrupted by the gravity of giant molecular clouds and other clusters. So, open clusters can easily disperse from its cluster. That's the thing about open cluster. Here in this picture you could see a jewel box cluster, one of the best southern sky open clusters to observe with a small telescope. So this is a prominent open cluster star captured by the astronomer. This is how the stars are classified broadly as globular cluster and open cluster. Coming to the spectral classification of stars. This spectral classification is made based on the absorption of light, absorption of atoms, molecules by the light coming from the star. This is the very basic thing about spectroscopy. In spectroscopy, elements present in the universe are found using the absorption lines or emission lines by that particular molecule, atom, matter, whatever it is. So that's the basic thing about spectroscopy. Here, classification of stars, spectral classification of stars have also done based on the absorption features present in the stellar spectra. This basic concept is used by Harvard University astronomers and researchers, so that it got the name Harvard Spectral Classification of Stars. So in this Harvard Spectral Classification of Stars, the absorption features present in stellar spectra allows us to divide stars into several spectral types depending on the temperature of the star. This Harvard spectral classification scheme in use today is the Harvard spectral classification scheme, which was developed at Harvard College Observatory in the late 1800s and refined to its present incarnation by Annie Jump Cannon for publication in 1924. Originally, stars were assigned a type from A to Q based on the strength of the hydrogen lines present in their spectra. You know, in spectroscopy, hydrogen absorption spectra is the very basic concept to classify the spectrum of atoms. Like that, here hydrogen lines absorption ability of star is used to classify it from type A to Q in 1800 itself by Harvard astronomers and scientists. Later, this Harvard spectral classification realized that there was significant overlap between the types, and some of the letters they used between A to Q were dropped. So in later case, they have dropped some of the letters assigned to classify the star because there is a overlap, significant overlap between the types of stars. Continuity of other spectral features was also improved if B came before A and O came before B in the spectral classification of stars. Finally, the spectral sequence ends with the sequence O, B, A, F, G, K, M. So this is the 7 spectral classification of stars. This sequence is ordered from the hottest star to the coolest star and is often remembered by the mnemonic, "Oh, be a fine girl or guy, kiss me." So this is a famous mnemonic, easily a youngster can remember to order the spectral sequence, to remember the spectral order of a star. "Oh, be a fine girl or guy, kiss me." The following table summarizes the main spectral types in the Harvard spectral classification scheme. So here O class, the color will be violet, temperature of the O class stars will be more than 28,000 Kelvin, then absorption lines, spectral hydrogen absorption lines, few visible absorption lines, weak Balmer lines, ionized helium lines. So like that, three properties are there in O class stars. Then coming to B class stars, color will be blue, temperature of that stars will be between 10,000 Kelvin to 28,000 Kelvin. If you examine the absorption spectra of this B class star, you can find the neutral hydrogen lines, more prominent Balmer lines. Like that, two spectral features will be there in B class stars. Then A class star, its color also will be blue, temperature will be between 7,500 Kelvin to 10,000 Kelvin. Strongest Balmer lines will be there, and other strong hydrogen absorption line will be there. This Balmer spectral lines is the another feature of the hydrogen absorption spectrum. Then coming to F class stars, blue and white, it will be a bluish white. Color of that F class stars will be bluish white. Its temperature will be between 6,000 Kelvin to 7,500 Kelvin. You can see a weak Balmer lines absorption in the F class stars, many lines including neutral metals. So metal absorption lines also will be there in the F class stars. Coming to G class stars, its color will be whitish yellow. Temperature will be between 5,000 Kelvin to 6,000 Kelvin. In the absorption spectrum, Balmer lines are weaker. Dominant ionized calcium lines will be there in the spectrum of G class stars. Coming to K class stars, its color will be orange and red. Its temperature will be between 3,500 Kelvin to 5,000 Kelvin. You can find many neutral metal lines in the K class stars. You could not see any Balmer lines or other hydrogen absorption lines. Instead, neutral metal lines will be most prominent in K class stars. M class stars, it's red in color. Its temperature will be 3,500 Kelvin. So strong neutral metal lines and molecular bands will be there in these M class stars. So Harvard spectral classification is done based on the higher temperature to lower temperature. So hottest to coolest. This is how Harvard spectral classification of stars has been done. Coming to the actual spectrum of the stars, which I have explained earlier, is given in the spectral form itself. This is the O class star. O class star is the hottest star. In that hottest star, you could see some visible part and hydrogen. This is helium part, hydrogen absorption lines. Then B class star, A class star, F class. So you can see some ion absorption lines will be there in F class stars. Then here in M class stars, you can see many absorption lines. All these dark black lines in the spectrum are all absorption lines. This is absorption spectrum of stars. Based on this, classification of stars are made as OBA, FGKM. Coming to the next type of spectral classification of stars, Morgan-Keenan luminosity spectral classification of stars, abbreviated as MK spectral classification of stars. This classification is primarily based on temperature. In Harvard spectral classification of stars, stars are classified from higher temperature to lower temperature. Here the main property, character used to classify is also temperature. So the Harvard spectral classification scheme assigns each star a spectral type, which is further divided into 10 subclasses depending on the absorption features present in the spectrum. For example, our sun has a temperature of about 5,700 Kelvin and is classified as G2 star. So here you could see the spectrum of G class star. So this G class itself further divided into 10 classes. In that 10 classes, our sun comes under the second class G2 category of stars. This classification scheme does not completely describe the star. This Harvard classification scheme does not completely describe the star, as it cannot distinguish between stars within the same temperature but different luminosities, so that this Morgan-Keenan classification is appended with the Harvard spectral classification, so that final form for the spectral classification of star is given. In other words, this Harvard spectral classification cannot distinguish between main sequence stars, giant stars and supergiant stars. For this reason, the Morgan-Keenan luminosity class was established. Originally, this Morgan-Keenan class originally contains Roman numerals between 1 and 5. So 1 have been divided into 1A and have been added. So this is the spectral classification of stars. This is MK spectral classification of stars. 1A to O, 1A. So this is a 1A, 1B, then 2, 3, Roman letter 3, Roman letter 4 is given for subgiants, then 5 is given for main sequence dwarf stars, then 6 is given for sub dwarfs, and D is assigned for white dwarfs. This is the MK spectral classification of stars. Coming to the next interesting topic in about stars is constellation, groups of stars. These groups is used to identify a region of the sky. Individual stars within a constellation generally have no physical relationship, as they are at a varying distance from our observation point on the earth. So Greek astronomers and Roman astronomers give different name for the group of stars they found in the sky. The constellation of Ursa Major has variously been identified as Ox and his handler by the Egyptians, as recorded in painting found in the tomb of Seti. The tail of a great bear by the Greeks and Native Americans is another cluster of stars, constellation of stars. So this is how stars are constelled. This is the Ursa Major constellation of star. According to Indian Astronomical Union, there are 88 constellation of stars are there. Out of that 88 constellation, Ptolemy has 48. Then the remaining things are assigned to different cultures existing in the world. So these constellations originally came from a variety of sources, including the myths and legends of Mesopotamia, Babylon, Egypt and Greece. So like that, different cultures kept on add different constellation for the constellation of stars. But according to International Astronomical Union, there are only 88 approved constellations are there. The modern constellation contains a mixture of mythological character like Perseus, Andromeda, Orion, animals. So like that things are there. Out of these 88 constellations, 12 constellations are used as zodiac sign in astrology. So people think that there is a connection between astronomy and astrology, but actually speaking, there is no connection between the proved connection between astrology and astronomy. Why these 12 constellations are taken as zodiac sign is, these 12 constellations exist in the path of the movement of the sun, so that these 12 constellations of stars are taken as zodiac signs by the astrologers. They are predicting things based on that astrologers. So this is the water bearer star. Then you can see this Aquarius in The position of 22.7 hours, 71 hours right ascension, declination 10.19 degrees. This is Aries. This is another constellation of star. You can find this Aries in northern hemisphere, right, with right ascension 3 hours, declination 20 degrees. This is the Cancer constellation, another prominent astrological or zodiac sign used by astrologers. You can view this Cancer constellation in northern hemisphere in the position of right ascension 9 hours, declination 20 degrees. This is Capricornus constellation. This Capricornus constellation can be located in the southern hemisphere with right ascension 21.02 hours, declination minus 22 degree hours. So this is of 12 constellations are used for the zodiac signs. So in this lecture we have seen the cluster of stars, globular cluster and open cluster. Globular clusters are roughly spherical grouping of stars that range from 10,000 to several million stars. Stars in an open cluster have a common origin. They formed from the same initial giant molecular cloud. Open cluster of stars contain only a few hundred number of stars. Then coming to the absorption features, it can be divided based on the temperature. Then Harvard spectral classification of star gave a mnemonic, "Oh, be a fine girl or guy, kiss me," to remember the group of stars. Then the International Astronomical Union specifies a definite set of 88 constellation of stars. So this is how stars can be learnt elaborately through this lecture. You can refer these links to understand more about the stars. Thank you.